Next topic, milling helical grooves. In milling helical groove, a complex helical movement is imparted to the workpiece, which involves a straight movement along the workpiece axis and rotation of the workpiece about the same axis. The workpiece receives the straight movement with the work table of the machine and rotation from the work table lead screw through change gears. The table is set to the spindle axis at an angle omega equal to the helix angle of the groove being cut. In milling a left hand groove, the table swiveled clockwise at an angle omega, and in right hand groove counterclockwise. The set angle for the table is omega is equal to arc tan IID divided by PSG, where D is equal to diameter of the workpiece being cut, PSG is equal to lead of helical groove. And there is the picture, and there are also two figures, right hand helical gear and left hand helical gear, as well as right hand arm and left hand arm. If the helix is determined by the lead angle alpha, the table should be set at an angle of 90 degree minus alpha. There are some figure, and there is a problem for you. To what angle must the milling machine table be swiveled to cut a helix having a lead of 250 mm on piece of work 40 mm in diameter? So the tangent of helix angle is here, pi multiply d, that means 3.1416 multiply d divided by lead of helix, that means 450. So the result is 0.2792. And from here we find our helix angle, and that is 15.36 degree. The kinematic balance equation of this chain for setting up change gear train A1 by B1 multiplied C1 by D1 is worked out provided that for every revolution of the workpiece, the work table of the machine travels by an amount equal to the lead PSG of the groove being cut. There is a figure. So that means we can write 1 multiply Z0 by Z multiply 1 into 1 into 1 multiply A1 by B1 into C1 by D1 multiply P1S is equal to PSG. With Z is equal to 1, we obtain A1 by B1 multiply C1 by D1 is equal to PSG divided by Z0 P1S, where P1S is the lead of work minus table lead screw, and the unit is in millimeter. Now there is a question. It is required to mill 6 right-hand helical floors with a lead of 600 mm. The blank diameter is 90 mm. If the pitch of the table lead screw is 7.5 mm, give complete information about the setup. Brown and sharp index plate. Plate number 1, 15, 16, 17, 18, 19, and 20. Plate number 2, 21, 23, 27, 29, 31, and 33. Plate number 3, 37, 39, 41, 43, 47, and 49. And here are the standard change gears for you. 24 multiply 2, 28, 32, 40, 44, 48, 56, 64, 72, 86, and 100. And this is the solution for this question. See here, n is equal to, for indexing, n is equal to 40 by 6. That means 6 multiplied 2 by 3 is equal to 6. 12 by 18 crank revolution. Choose plate 1 brown and sharp and select the whole circle 18. The crank should be rotated 6 complete revolution plus 12 holes out of 18. Now for helix, 10 omega s is equal to pi d divided by t helix. That means pi multiplied 90 divided by 600, and that means 0.471. Then omega s is equal to 25.23 degree. The milling table should be set counterclockwise at an angle of 25.23 degree, where change gears is equal to A1 by B1 into C1 by D1 is equal to 40 multiply TIS divided by T set. That means 40 multiply 7.5 divided by 600, because TRS is equal to 7.5 and T helix is equal to 600. And we can write for this 24 by 56 multiply 28 by 24. Then A1 is equal to 24, B1 is equal to 56. C1 is equal to 28 and D1 is equal to 24 teeth. Now, there is a reference book for you. Shop Theory, General Book, written by James Anderson, Tata McGraw-Hill, New Delhi, 1974. Another one is Machining Technology, Machine Tools and Operations by Helmi A. Yusuf, Hassan El Khofi. There is a question for you. Calculate the change gears required to cut a helix having a lead of 500 mm on a workpiece using a standard set of gears. The milling machine lead screw has a pitch of 5 mm. The normal change gears in set are 24, 24, 28, 32, 36, 40, 44, 48, 56, 64, 72, 86, and 100.